Hello, dear students. I welcome you all on behalf of Shri Jayendra Rank Zone classes. In previous lectures, we have seen the light, properties of light, reflection, refraction, total internal reflection, then refraction by spherical surfaces, reflection by spherical mirrors, mirror formula, lens formula, etc. Now, in this lecture, we are going to study about the refraction through a glass prism. So let us begin. This is a glass prism ABC whose base is ABC. Here the light ray is incident PQ. PQ is the incident light ray. LM is the normal on surface AB. At point Q, light is traveling from air to glass. So it is moving from rarer to denser medium. That's why it will bend towards the normal. QR is the refracted ray inside the glass slab. At point R on surface AC, light is again moving from glass to air. So it will bend away from the normal. So RS is the finally refracted ray. RS is called emergent ray. Angle of incidence on surface AB is I and angle of refraction is R1. Angle of incidence on surface AC is R2 and the angle of refraction made by emergent ray with normal is called angle of emergence. Here, the angle made by actual direction of incident ray with emergent ray is called angle of deviation delta. We want to find the relation between delta I and E. From triangle EQR, triangle EQR is such that this exterior angle is delta, this angle is R1 and this angle is R2. So this is 90 minus R1 and 90 minus R2. From that we can write delta is equals to 90 minus R1 plus 90 minus R2. Or we can say it is I minus R1 plus E minus R2. So delta can be written as I plus E minus R1 plus R2. Now, the angle between emergent ray RS and the direction of incident ray is delta. Now, in the quadrilateral AQNR, in this quadrilateral, sum of all the angles should be 360 degree. So, we can write that angle A plus 90 degree plus angle Q and R plus 90 degree is equals to 360 degree. So angle A plus angle Q and R is equals to 180 degree. Now in triangle Q and R, we can write R1 plus R2 plus angle Q and R is equals to 180 degree. So angle Q and R can be written as 180 degree minus R1 plus R2. Put the value of angle Q and R in equation 2. So from equation 2, we can write angle A plus angle Q and R can be replaced by 180 minus R1 plus R2 is equal to 180 degree. So we can write angle A is equals to R1 plus R2. This is one very important relation. Here angle A can be simply written as A, which is called angle of prism. Now put the value of A in equation 1. So from equation 1, we can write delta is equals to I plus E minus E. So this is the equation of deviation, angle of deviation for prism. Now, if we draw the graph between angle of deviation and angle of incidence, then the graph would appear like this. The minimum value of deviation is called minimum deviation delta M. This is the minimum deviation. When deviation is minimum, I and E will be same. Angle of incidence is equal to angle of emergence. If angle of incidence is equal to angle of emergence, then we can also write that R1 is equals to R2. So when delta is equals to delta minimum, angle of incidence is equal to angle of emergence and R1 is equals to R2. So we can write A is equals to R1 plus R2. But R1 and R2 are same. So R1 is equals to R2 can be written as A by 2. This is for minimum deviation. And the minimum deviation is 2I minus A. So angle of incidence can be written as A plus minimum deviation divided by 2. Now, if we want to find the refractive index of prism, we can apply Snell's law on surface AB. This is angle of incidence I and angle of refraction R1. So at this point, if we apply Snell's law, we can write N1 sine I is equal to N2 sine R1. So N2, if light is incidenting from air, then N1 is equals to 1 for air. So N2 can be written as sine I can be replaced by E plus minimum deviation by 2 divided by sine of R1, but R1 is A by 2. So this is the formula for refractive index of prism that we can find when deviation is minimum. Now, for small angle of prism, They are also called thin prisms. Maybe they will appear like this. They will have very small angle of prism. Minimum deviation is also very small. So refractive index can be given as A plus delta M by 2 divided by A by 2. So refractive index is A plus delta M divided by A. So deviation, minimum deviation will be N2A minus A. So the minimum deviation is N2 minus 1 into A. Here N2 is the refractive index of glass of which prism is made. So in general, we can write refractive index of glass minus 1 into A. It is notable that the thin prism does not deviate light much because the deviation angle is lesser. Let us see some question based on the prism. The angle between the emergent ray and incident ray is called angle of deviation. As the angle of incident increases, what will happen to angle of deviation? It will first increase and then, it will first decrease and then increase. We can derive it from graph. First angle of deviation is decreases and after achieving the minimum value, it will start increasing. So option D is correct. Now let us understand the dispersion by prism. When a white light is passed through prism, it is divided in its constituent colors. This phenomena is called dispersion of light. So let us write down the definition. When white light is passed through a prism, it is divided into its constituent colors. This phenomena is called dispersion of light. This is due to the refractive index of prism. Refractive index of prism is different for different wavelengths of light. Here in this figure, we can see that light is incident, white light. This is the actual direction of incident ray. All the lights, 7 colors of light, are deviated at different angle. The angle of deviation for violet color is maximum and angle of deviation for red color is minimum. So we can see that violet light is deviated the most, and red light is deviated the least. What is the angular dispersion? How can we define the angular dispersion based on this? It is the difference in angles of deviations of any pair of color. That is called angular dispersion. In the previous diagram, we can see that this theta is the angle of dispersion between violet and red light. So let us define the difference in the angles of deviations of any pair of colors is called angular dispersion. The deviation of violet color is delta V, and deviation of red color is delta R. Delta V is deviation of violet color, and delta R is the deviation of red color, and delta Y is the deviation of yellow color. So deviation of yellow color is taken as mean deviation. We can write deviation of red violet color as refractive index of violet color minus 1 into A. Deviation of red color as refractive index of red color minus 1 into A. And deviation of yellow color as refractive index of prism for yellow color minus 1 into A. The angular dispersion theta can be written as delta V minus delta R. That is mu V or NV minus NR into A. This is called the angular dispersion. Now, let us understand what is dispersion power. Dispersion power indicates the ability of the material of prism to disperse the light ray. The dispersive power omega is defined as the angular dispersion between red and violet colors, that is theta, divided by their mean deviation. So delta V minus delta R is equal to mu V minus mu R into A. So omega can be written as delta V minus delta R divided by mean deviation is delta V plus delta R divided by E. So omega can be written as, this mean deviation is the deviation of yellow color. So delta V minus delta R divided by delta yellow. The angular dispersion is denoted by theta. So omega is simply theta upon delta Y. We can also write it as refractive index of violet minus refractive index of red color divided by refractive index of yellow minus 1. That is delta n upon n minus 1. The dispersive power is, it is the independent of the angles of prism and angle of incidence. It only depends on material of prism, that is its refractive index. The dispersive power of flint glass prism is greater than that of crown glass prism because it depends on the refractive index. This is most commonly asked conceptual question in exam, that dispersive power of flint glass prism is greater than the dispersive power of crown glass prism. If two prisms of angle A and A dash of refractive indices N and N dash are placed together, then how can we find the total deviation? We have two prisms. One is of angle of refraction or prism angle A and another of prism angle A dash. Refractive index N and refractive index N dash. So total deviation will be delta is equals to delta 1 plus delta 2. That is ny minus 1 into A plus ny dash minus 1 into A dash. The total deviation will be theta 1 plus theta 2, that is ny minus nr into A plus ny dash minus nr dash into A dash. Now, what if we want the deviation without dispersion? That means when we combine two glass prisms, we want light to get deviated, but we do not want the dispersion. So if we incident white light as the outcome, we require white light only. We have taken two glass prisms over here. The white light is incident in prism 1, that is crown glass prism. It is divided into its 7 constituent colors. When it is incident in another flint glass prism, after recombination, finally we will have white light. So when two prisms of different materials and specified angles, they should have same angle of prism, are combined such that ray of light passes through the combination without dispersion, is called achromatic combination. This type of combination is called achromatic combination. In this situation, the light ray may or may not suffer deviation. So delta is not equal to 0, but theta, angular dispersion, is 0 as there is no dispersion. So what will be the value of delta? Let us find out. The theta is 0, so we can write NV minus NR into A plus NV dash plus NR minus NR dash into A dash is equals to 0. So we can write NV minus NR upon NY minus 1 into A into NY minus 1 plus NY dash minus NR dash into A dash divided by NY minus 1 to NY dash minus 1 is equal to 0. So basically we can write that omega into delta for crown glass plus omega into delta for flint glass. This total is 0. The total deviation produced is delta is equals to deviation by crown glass minus deviation by flint glass. So it can be written as ny minus 1 into a minus ny dash minus 1 into a dash. So delta can be written as theta c upon omega c minus theta f upon omega f, because delta can be written as theta by omega. Now, let us understand the phenomena in which we are combining two prisms such that we want dispersion without deviation. Light ray should not get deviated. Here we have incident of white light. The dotted line is the actual direction of incident light ray. It is passed through a prism. It is dispersed. The dispersed 7 light colors are passed through another prism. Due to this second prism, there is no further dispersion or recombination, but simply light rays are just deviated. They are deviated in such a manner that the final direction of yellow light and the actual direction of white light are parallel to each other. The light rays are parallel to each other. So the angle between them will be 0. So deviation angle will be 0. So if the angles of crown and flint glass prism are so adjusted that deviation produced is 0, then it is called dispersion without deviation. For this, we want delta 0 and dispersion angle not 0. So we can write refractive index of y minus 1 into a plus ny dash minus 1 into a, that should be equal to 0. This can be replaced by ny can be written as ny minus 1 upon nv minus nr. We are multiplying it and dividing it with nv minus nr into a plus ny dash minus 1 upon nv dash minus nr dash into nv dash minus nr dash into a is equal to 0. So we can write theta c by omega c plus theta f by omega f is equal to 0. Theta are the angular dispersion and omega is the dispersive power. In this case, the dispersion produced by flint glass prism is opposite to crown glass prism. So the net angular dispersion can be written as NV minus NR into A plus NV dash minus NR dash into A dash. Simply theta is equals to theta 1 plus theta 2. Or we can also write it as theta is equals to NV minus NR upon NY minus 1 into A. We have multiplied and divided by NY minus 1. Same way for flint glass, we have divided and multiplied by NY dash minus 1 into A dash is equal to 0. So we can write theta is equal to omega C into delta C minus omega F into delta F. This is the condition for dispersion without deviation. Let us see some question. The dispersive power is of the angles between on which it depends. It is independent of angle of prism and angle of incidence. Next, the dispersive power of flint glass prism is less than, greater than, or equal to on crown glass prism. The correct answer is greater than the crown glass prism. Now, let us understand one phenomena that occurs due to dispersion of light, that is rainbow. Rainbow is formed by dispersion of sunlight falling on raindrops. We observe the rainbow in a direction when our back is towards the sun. This is also a question asked in medical examination of NEET 2020. What is the condition to observe rainbow? So let us write down. It is formed by dispersion of sunlight falling on raindrops, and we can observe the rainbow in a direction when our back is towards the sun. We can have two types of rainbows. One is primary rainbow and the other one is secondary rainbow. Let us see the formation of these rainbows one by one. First one, let us see the primary rainbow. The common rainbow is primary rainbow. It is a colored band having red on the outside and violet on the inner side. It is formed due to refraction and one reflection of light falling on the raindrops. So there will be two phenomena. There will be 2 refraction and 1 reflection that occurs in the formation of rainbow. Here we can see that white light is incident on 2 water droplets. Light is incident on the spherical drops. Due to dispersion, it is divided into its constituent colors. After total internal reflection from the second surface of water drop, the light rays will come out of the water drop and enter the eyes of observer. The violet light will be seen in upward direction and red light will be seen in downward direction. We can find this angle made by violet light is 40 degree and angle made by red light is 42 degree. Now, what actually happens? Let us check. This is a raindrop. The sunlight is incident on one surface of a raindrop. Now, when it enters the raindrop, the light is dispersed. From the second surface, there is total internal reflection of these lights, 7 colors, and light is finally reflected out in the atmosphere. The angle between the actual direction of sunlight, that is horizontal, and red light is 42 degree. And the angle between violet and horizontal is 40 degree. Now, let us see how secondary rainbow is formed. It is formed due to 2 refractions and 2 reflections of the sunlight falling on the raindrops. It is a color band having violet on the outside and red on the inside. Violet on outside and red on the inside. It is a 4-step process. The intensity of light is reduced at second reflection and hence primary rainbow is fainter than the secondary rainbow. It is fainter than the secondary primary rainbow. Secondary rainbow is fainter than the primary rainbow. Now, what is the condition for the visibility of secondary rainbow? It is visible only when the altitude of sun is less than 42 degree. It is visible only when the altitude of sun is less than 42 degree. A complete rainbow can be seen from a flying aeroplane. Let us see how secondary rainbows are formed. This is first falling drop. Sunlight is incident. It is refracted inside from the second surface. It is internally reflected. And when it comes out, the violet light is on the downside and red light is on the upside. Now again sunlight is incident on second drop. Again dispersion happens. So this is secondary rainbow. The angle made by red light with horizontal is 50 degree, and angle made by violet light with horizontal is 53 degree in the case of secondary rainbow. Now let us understand the another phenomena of white light or sunlight, that is scattering of light. First of all, let us understand what is scattering. Scattering is the process of emission of light by molecules of a medium in all possible directions. After absorbing the incoming radiation. So in scattering of light, the atmospheric particles or medium particles will first absorb the radiation, and then it will emit the light in all the possible direction. Here we can see two phenomena of sunlight that happens due to scattering of light. During the daytime, sun is nearly overhead. It is above the horizon. So the distance of atmosphere through which light travels in atmosphere is lesser. In that situation, less blue light is scattered. That's why most all other lights are scattered. Only blue is less scattered. That means blue is absorbed most. Blue is absorbed most. That means the sky will appear blue. But when it is below the horizon, sun is near the horizon or below the horizon, blue gets scattered away and sun appears reddish. So let us understand why does this happen. In scattering, if wavelength of radiation remains unchanged, the scattering is called elastic scattering. Otherwise, it is called inelastic scattering. Light of shorter wavelength is scattered much more than the light of longer wavelengths. So we can say that intensity of scattered light is inversely proportional to wavelength. Intensity of scattered light is inversely proportional to wavelength power 4. Here it is called the Rayleigh scattering relation, and it depends on size of molecules also. If size of molecule is very less than the wavelength of light incident, scattering is called Rayleigh scattering. Now, let us understand by the phenomena of scattering, why does the sky appear blue? The raindrops, large dust particles, ice particles scatter with nearly equal wavelengths. Clouds with water droplets are generally white. They appear generally white, that we can see in image. So what is the reason behind the sky appearing blue? Blue color has the shorter wavelength than red. Hence, blue is more scattered than red. We know that intensity of scattered light is inversely proportional to wavelength power 4. So the light having least wavelength will get scattered more. As blue light is scattered more, sky will appear blue. Same way, what is the reason behind the reddish color of sun during sunrise and sunset? At sunrise and sunset, the sunlight has to pass through a larger distance in atmosphere because sun is below horizon. If this is the observer, light has to pass through larger distance in the atmosphere. So mostly blue color and other shorter wavelength color are scattered. So the least scattered light will reach to the observer, least scattered light. Which one is least scattered light? Red and orange, because they have longer wavelength. Only will reach to the observer. So the sun will appear reddish or orange during sunrise and sunset. So what is the reason behind the reddish color? It is the scattering of light. Rainbow is an example of which phenomena? It is the example of dispersion of light. This is all for today. Thank you.